Okay, one more video involving derivative connections. This one you can actually do on your graphing calculators. You have two functions here, actually one function and its derivative. The function, you can see the black curve, f of x is 2x cubed minus 3x squared plus 1. And the red curve is the derivative of the black curve. I'm sure you can derive this. I've got it down here anyways. F prime 6x squared minus 6x. Basic couple of polynomials right there. If you put those into the graphing calculator, graph them simultaneously, zoom in from a Zoom 4 initial graph, you'll get a picture that looks pretty close to this. You can use my picture, you can use the one on your screen, whatever works for you. What I would like you to do is work with me as we kind of connect the two curves, okay? So again, the black curve is our function. Let's look at our function. Our function is increasing, and then it decreases for a short amount of time, and then it increases again, okay? Notice what's happening to the red curve, the derivative, when the original f curve, the black curve, is increasing, okay? So we're increasing again up until we hit the y-axis, and we're increasing after x equals 1. While that's happening, the red curve, the derivative, here and here. In both cases, the derivative is above the x-axis, okay? The derivative, the red curve, the graph of the derivative is positive. It's above the x-axis, which means it's positive. We know that from geometry from a long time ago. The black function is increasing at the same time that the red function is positive. Okay? The original function increases when the derivative is positive. Yes, the derivative is decreasing right here. That doesn't matter. We'll get to that later. Okay? Right now, all you need to focus on is the fact that the derivative is above the x-axis in these two spots, and on those same intervals, the original function is increasing. It's going up as we go from left to right. Okay? What about that short time in between? Look at this interval right here. From 0 to 1. X equals 0 to x equals 1. During that short amount of time, our black function is, the graph is decreasing. Okay? Well, while the graph is decreasing, here's our red derivative. What's going on with the red derivative? Well, it's decreasing and increasing, but again, we're ignoring that. We don't care about how the derivative is changing at this point. We only care about whether the derivative is positive or negative. And this derivative is most definitely negative, and we know that because the derivative is below the x-axis. So when the derivative is negative, that was the exact same time that the original curve was decreasing. How about that spot right there? We all agree that that's a relative max for our function, okay? The function has a relative max. What's going on with the derivative? Well, yeah, the derivative is equal to 0, so we have a critical point. Okay, but more importantly, the derivative was positive, and then it became negative. Okay, the derivative changed from positive to negative, and at that time, the function had a relative max. Okay, and conversely, when the function has a relative min, yeah, it's on the x-axis. That doesn't matter. Okay, it's a relative min. Right before and right after that point, the graph is above the relative min. It's not on the x-axis, but we have a relative min right here, and at that same time, the red derivative changes from negative to positive. It goes from being below the x-axis to above the x-axis. When red changes from negative to positive, the original function, the black function, has a relative max. Excuse me, relative min. Okay, so there's both curves happening simultaneously. Hopefully, with these videos, you're feeling more comfortable about the connections between a function and its derivative.